Nonverbal communication using facial expressions plays an essential role in face-to-face communication, but it remains under-investigated in VR. Current techniques use either face tracking, using cameras, sensors, or the microphone to detect the user's facial expression from their voice. However, these isomorphic techniques are limited to what users can convey with their own face and have recognition issues. Non-isomorphic techniques can overcome these limitations with interaction techniques based on input devices. Some VR social applications use non-isomorphic techniques, like a marking menu, but they are limited to only a few expressions. We present the design of a set of new non-isomorphic interaction techniques for controlling an avatar's facial expression in VR. Our techniques cover both the selection of an expression and the control of its intensity, duration, and ending. First, we present the interaction techniques for the selection of expressions. Raymoji presents a panel of emojis in front of the user, similar to the emoji menus present in desktop and mobile social applications. The user aims at the desired emoji, and a preview of the expression is shown on the puppet face. Then they press the trigger with the index to activate the expression on their avatar. Emo Touch displays a circular menu controlled with a touchpad of a VR controller. The user hovers over an emoji to preview the expression on the puppet face, and presses the touchpad or the trigger to validate the selection. Emo Jest allows the user to select a facial expression by drawing gestures on the touchpad. Finally, Emo Voice uses speech recognition to control the facial expression. The user presses the touchpad, says a keyword, then releases the touchpad to trigger the expression corresponding to the keyword. From the results of our first experiment, we implemented Emo Ray, which combines the strengths of Raymoji and Emo Jest. It shows a circular menu in front of the user, and raycasting is used to select the expression. Now we present the interaction technique to control the expression's intensity, duration, and ending. The first technique maps the controller's elastic trigger position to the intensity. The ending of the expression is triggered after a timeout of 1 second from the release of the button. The second technique maps the controller's tilt to the intensity. The expression ends when the user releases the selection button. The third technique maps the magnitude of the controller acceleration to the intensity. We filter this value with a 500 millisecond moving average to avoid unwanted intensity oscillations. The fourth technique maps the length of a virtual white segment to the intensity. The user can manipulate the length of this segment, for instance with the ray of Emo Ray. For the fifth technique, after the user has selected an expression, they can adjust its intensity by moving around the cursor in the menu. The intensity is null at the center and maximum on the edge. 2 controlled experiments helped us design an interaction technique combining the strengths of each approach that we call Emo Ray E. It was then evaluated in a final ecological study showing it can be used in social applications, like a VR meeting application, to control the facial expression of an avatar in real time.